So in the previous lecture, we began our discussion on hybridization, and we developed sp hybridized orbitals. So we essentially took one s orbital, we took one p orbital, we combined them, and we formed two different sp hybridized orbitals. Now we're going to look at sp2 hybridized orbitals. So let's suppose we want to construct a BH3 molecule. Now in order to construct this molecule, we need 3 H atoms and 1 boron atom. Now, boron has 5 protons, so that's 5 electrons. 2 go into the 1s, 2 go into the 2s, and 1 goes into the 2p, so we have 3 valence electrons. Now the H atom each has 1 electron, so the 1 electron goes into the 1s orbital. Now before these atoms can combine to form our BH3 molecule, hybridization of boron must take place. The question is, how many hybrid orbitals should boron form before this molecule can be created? The answer lies in this molecule itself. How many times does boron bond to H? Well, since there's 1 boron and 3 H atoms, that means there are 3 different orbitals. So that means we must develop 3 hybrid orbitals. So that means we can no longer use sp hybridization because sp hybridization produces only 2 hybrid orbitals, and we need 3 as we see in this case here. So that means we're not combining s and p, but we're combining 3 orbitals. And these 3 orbitals are the 2s orbital, the 2px orbital, and the 2py orbital. So we combine these atomic orbitals of the boron atom and we form 3 identical sp2 orbitals or hybrid orbitals, and these guys look like this hybrid orbital here. The only difference is they all lie in different directions, so they point in different directions. So that means because we're combining 2 2p orbitals and 1 2s orbital, we're going to have 66% p character and 33% s character. So now that we formed the 3 different hybrid orbitals, we are ready for these orbitals to interact with the 1s orbitals of the H. So we take 3 1s orbitals, we combine them with 3 sp2 orbitals, and we form the following picture. So here we have our boron atom. The nucleus is in the middle here. It's not shown. We have one sp hybridized orbital pointing into the page, into the board, and it's bonding to one of the s's. One is coming out of the board, and that's bonding to a second 1s orbital, and the third is lying on the board, and it's bonding with the third 1s orbital. And here we have our BH3 molecule that also looks like this. So once again, the boron nucleus, one bond is coming out of the page, the second bond is going into the page, and the third is going this way. Now if we graph the x, y, z axis, we see that this molecule lies on the same plane. All the bonds lie on the same plane, so that means since we have 3 angles, each angle must be 120 degrees. So once again, let's review. So what is an sp2 hybridized orbital? Well, an sp2 hybridized orbital is simply the combination of 3 different atomic orbitals found within an atom. In this case, it was the boron atom. When these 3 different atomic orbitals combine, they form identical hybrid orbitals. Remember, the amount of orbitals that go into the combination must equal to the amount of hybrid orbitals we form. So if we include 3, if we input 3, we must produce 3 orbitals.